Hadoop nodes, different nodes in which Hadoop can be used. So there are three modes in which Hadoop can be um used. So first one is standalone mode, second is pseudo distributed mode, that is single node clustered, and the third is fully distributed mode, multiple node clustered. So why these three has been distributed is because sometimes data is being used as a separate machine in a separate machine, and all nodes in a separate machine. Sometimes data and all machine has been that is all nodes has been kept in a single machine, and sometimes all nodes are working as a different machine and data is distributed in different nodes in a cluster, as we have seen in case of HDFS. So due to these types of variation, there are three types of modes has been created for Hadoop in which Hadoop can be used. So first one is standalone mode. What is the meaning of standalone mode? Standalone is single, which can handle everything. So in standalone mode, only one node, one system is there, and only this system is working, is being used for data purpose, data storing purpose, as well as for your nodes also. So all nodes like data nodes, job tracker, task tracker, name node, these all are in single machine. So data is in your single machine, all components required are in your single machine, so everything is in single machine. So these nodes are nothing but a algorithm. For this standalone mode, these all nodes are not separate machine, they are working as a algorithm. So each one is behaving as an algorithm in the system, and by behaving that, it is giving its serving their purposes. So basically this is the default mode of Hadoop. Okay, now as data are stored in this single system, and as we know that for HDFS, for implementation of HDFS, there has to be lots of nodes and backups of the nodes. Each node has to be make by default 3 backups. So in this node, how that is possible? So HDFS has not been used in this first standalone mode, because all data in a single machine, how can it be a HDFS implementation? So there is no HDFS in case of default, that is standalone mode. So what it is done, it is used for debugging purpose. Okay, so there are four things we now input, of course input is will be taken from this local system and output will be in this local system itself. It is used for debugging purpose, and no custom configuration is possible because it's a single machine. So what custom can be done? As we have understood, in case of HDFS, there is a custom configuration that 64 MB and 128 MB, like this you can configure it as if you are your system admin. But this custom configuration is not capable in this thing, so basically used for debugging purpose. So that's the use of standalone mode. So let us understand what now pseudo distributed mode. As you can understand, sir, not pseudo means not fully distributed, it's pseudo distributed. It will make you feel that it is distributed, but actually it is pseudo distributed. That means which is not actually existing in distribution. So it gives you the feeling of distributed system. So it is also known as the single node cluster. Okay, so let us understand it. The second one, that is pseudo distributed mode, that is single node cluster. In this case, data has been kept somewhere. Suppose in data center you have kept your data, and there is in a single machine another. So here HDFS has been used. So you are using your data center for storing the data. There is a system in which that is HDFS, in which your data has been kept. Now your system here is your machine, and in this machine your all nodes, that is name node, job tracker, task tracker, uh, job tracker, task tracker, and your data node. Not data node actually here. Here has to be, okay. So data node is here. So all nodes are present here. Working nodes are present here, and data is in different machine. So in this case, data kept in somewhere else in else machine, and the all nodes working in this machine. So it is giving you the feeling of distributed, not fully distributed, because all nodes are kept in a single machine and the data is in different machine. So this is working as a distributed, and these all nodes are working as algorithm. So it is a pseudo distributed mode in which data kept somewhere else and all nodes are kept in a single machine. That is your distributed, pseudo distributed, that is single node. Now the third one is fully distributed mode, that is multiple node cluster. So fully distributed mode means everything will be in separate node. So your data is in data center as data nodes, as we use it is HDFS system has been used here. Now your name node is one system, your job name node is your single system, your job tracker is another single system, and everything that is task tracker is single another system. Job tracker, task tracker, data nodes. Data node is your single system again. So these all nodes are working as a single machine. Earlier it was working as algorithm. Now in case of fully distributed mode, all nodes are working as single different machines. So in this, that's why it is known as the fully distributed mode, in which you are keeping your data in your uh, data center, and there you got some nodes which can be used as a component to work upon this data, and from that you can get the output. That's why it is a fully distributed modes of Hadoop. Okay, so now we will understand by an example that we will not use this and this. We will use this third one, fully distributed. If we are able to understand the fully distributed mode, then we can easily understand the 2 and 1, that is the standalone mode and pseudo distributed mode. So we will now discuss one of them, that is fully distributed mode, with an example, so that we can understand how the whole Hadoop system is working. Okay, so let us start that. Okay, let us understand the whole Hadoop system as a fully distributed mode. Okay, so in fully distributed mode, each and every node will be in a separate, working as a separate machine. So let us understand that by taking an example of a client who want to store the data of 400 MB. 400 MB is very huge data. Sorry, it's very less data, but I am taking it as an example for explaining purpose, so that it can be correlated and can be in understanding very easily. For 64 MB each and every block will be used. So I am supposing that 400 MB of data is internally about 400 terabytes or petabytes of data is actually, which is very huge data. Now internally I'm supposing it, that's why it is a big data for this Hadoop data center. And 400 MB data will be divided from this okay, let's start first. Client will send 400 MB data to this whole Hadoop system in a data center existing. Okay, now when it will come to Hadoop will first choose that there are, of course, in a data center lots of cluster is available. So in which cluster, in HDFS mode, in which cluster the data will be going, will be given by the will be directed by this whole Hadoop system, that in this cluster you want to, it will be stored, or in this cluster, or in different cluster. So there are one cluster, this is cluster 1, this is cluster 1, this is cluster 2, and so on. There are lots of clustered, and there's clustered n. So I am just here showing only 2 clusters in a data center, but actually there is lots, huge number of clusters available. Now data will, foreign data will come to Hadoop, and it will be decided by the whole Hadoop system, that is HDFS. In case of that, will be decided that in which cluster it will be stored. Suppose the name node, this name node has been chosen, that means this cluster 1, sorry, the cluster 1 has been chosen as storing for the 400 MB of data. Fine. So as we know that for a single cluster there is a one single name node, one single job tracker, and lots of task tracker, and lots of data nodes for the single cluster available. So this one is satisfying for a single, this one is whole, this is your single cluster. Again this whole is your single cluster. So we are taking example of this one. Suppose data for an we came to Hadoop, it has been assigned that to name node this. For the cluster 1's name node, data will come to first name node, and it is the name node who know everything that in which data node the data space is available for storing. So data will be coming to chosen cluster, and in that cluster first the data will come to the name node. Now name node, what it will do, that it will split the 400 MB data, and I am taking it as an example that each block of the data nodes has been taken as 64 MB, not 128 MB. I'm just taking, it's the system admin who can decide that whether block size will be 64 and 128 MB as we have discussed earlier. So I'm taking 64 MB as a block size. Now when block size is 64 MB, then how many numbers of block will be generated? So your total, and each size of the block is 64 MB. So it is a 50, 8 6 are 48. Okay, so 6 blocks plus 1 will be fully filled, and 1 block will be not will be partially filled. So 6 block will be used, 6 plus 1, 7 blocks will be used. Okay, so 64. Okay, so total 384 MB data will be fully stored in a block of 6. Fully will be 6 blocks will be full, and 16 MB of data will be filled up in another block, that is the 7th block, which will be partially filled actually. Okay, as we have understood that 6 blocks will be fully filled for the 400 MB of data, and the 1 block which will be partially filled with 16 MB of data. Now total 7 blocks will be required for the storing 400 MB of data. Now that 400 MB data will come to the name node, and it is the job of the name node which will get the information about the client, that is the name of the client, name of the company of the client, username, password, everything about the client will be stored in the name node first. Then it will assign the date that 400 MB, it will split actually, it will split the data 400 MB into number of blocks, that is 6 block, and the 1 block 7 block will be, and that 7 block will be stored where, depending on the which data node is empty. Now as we understood that 7 blocks will be required to store the 400 MB of data. So that 7 blocks is split, 400 is splitted in 7 different blocks. So each different block is known as your input split. What is that? Input split. So 400 MB of data has been taken, and it is splitted in 7 blocks, and that number 7 blocks is known as input split. So number of blocks will be required to store the data is your number of input splits required. Okay, so 400 MB of the data has been came, which is splitted in, and it will be stored as 7 input splits. So let us take that there are those 7 input splits are such that first input splits is a.txt. First input split is your a.txt of size 64 MB. Second is b.txt of size 64 MB. Third is c.txt, d.txt, e.txt, f.txt, and g.txt. So this is also 64 MB, also 64 MB, also 64 MB, 64 MB, and 16 MB. So these 7 files has been we obtained. We got our data as a 400 MB of data, 400 MB of data, and it came to Hadoop, and it has been divided in 7 input splits, and each 7 splitted here are such files that a.txt, b.txt, c.txt, d.txt, e.txt, and g.txt, and 6 are fully filled, that is in 64 MB, and 1 is partially filled, 16 MB. So these are going to be stored. So now storing 400 MB data is okay, can be stored in a single data node also, because single data node is having that much of capacity of terabytes, and which can now 400 MB can easily be stored. But there is two possibility that in that data node there is no that much empty space has been, it is not fully empty. It is not even 400 MB of the size of that data node has not empty. So we can store that 400 MB data. We should be storing that 400 MB of data in different data nodes, because all data nodes is not empty. Suppose this has empty of space empty is of 100 MB. This has space empty is 200 MB. This has empty space is 300 MB. So 100 MB will be stored here, 200 MB will be stored here, and 300 MB will be stored here. This one, so that all this file are not going to be stored in a single data node. First of all, the second reason for it that all files are not going to be stored in a single data node is that processing the whole file in a single system will make it slower. So we need a parallel processing, so that the processing can be faster, and that can be achieved by keeping those data in different data nodes, because on different data nodes different process will work, and ultimately the result will be combined, so that the work will be in different data nodes work will be partial work will be done, and it will be speedily done. So all 400 MB, if we put all 400 MB data in a single data nodes, then only one process will be working here, and it will make it will take lots of time. So instead of that, what we do, that we will store in different data nodes the whole different files. So this will make a parallel processing. Okay, so suppose that 400 MB data is divided in these 7 blocks. Suppose a.txt is stored in these data nodes. a.txt is stored in data node 1, a.txt, b.txt. Okay, in this c.txt, in this d.txt, in this e.txt, here it is f.txt, here it is g. So these data nodes has been stored now. After storing the data, all information will be kept as a metadata in name node, so that it can understand that which data has been stored, which file and what type of file is stored in which data node. So all information is stored in name node. So and another thing, that each data is copied in 3 as default. Okay, so copy of this data node 1 will be copied in some, suppose data node 4, data node 7, data node 8, data node 9. So suppose copy of this data node is copied in this data node, in this data node. So 3 copy of the data node 1 is already available. This information is also stored here in this name node, that data node 1 copy is stored in data node 2, in data node 3. Similarly, data node 2 copy is stored in some another data node. Data node 3 copy 3 copy of the, more 2 copy of the data node 3 has been stored in data node 4, data node 5. In this way, each data node is having 3 copy at a time. So those information is also stored in name node. Okay. Now, after storing, the failure has been also recovered here. How? So if a data node gets failed, so this information, how name node can we can understand that which data node has been failed. So as we have earlier discussed, that there is a heartbeat which gives the updates the information about this data nodes to name node after each 3 seconds. So after each 3 seconds, all data node will be talking, contacting with name node about their hardware information and the change in the file. So and the location of the file if it is has been changed. Okay, if changed, then it will be sending. So suppose data node 1 has been failed. So this information, how name node will be understanding. So data node 1 will stop giving the heartbeat in every 3 seconds. So suppose in first 3 seconds, data node 1 in first 3 seconds has not sent the heartbeat. Okay, in second 3 seconds it is not also, and so on. So after 30 seconds, that is after 10 heartbeat, after 10 heartbeat, suppose this has been set in name node, that if our data nodes do not contact even after 30 seconds, that is after 10 there is no heartbeat has been sent in 30 seconds, that name node will, then the name node will understand that that data node, that is here in case of data node 1, is either failed or got hanged. So what it will do, if it is failed, then it will be replaced by suppose this copy of data here is stored in data node 1, data node 2, data node 3. So data node 1 copy is also in data node 2 and data node 3. So name node will now make data node 2 as a primary, and data node 3 will be another copy, and on another copy of that, that is data 1 has been failed. Suppose data node 1 has been failed, so that data of the data node 2 corresponding to data node 1 will be copied in another, so that it at a time 3 copy of the data can be achieved. So another copy of the data node 1 data will be stored in another data node, so that data node 2 will be, now this has been failed, so that's fine, remove it. Now data node 2 is having, data node 3 is having the data, and another node will be also kept there, in which the data node 1 copy data of the data node 1 copy will be stored. So suppose that is data node 6. So in that data node, now the copy of the data is in data node 2, data node 3 and the data node 6, and data node 1 is totally dead. Now data node will be replaced by the people, by the admin of this whole cluster, and it will be replaced by some new data. But data node once data is not lost, it is already in was already in data node 2, data node 3, and now another copy of that data has been made in data node 6. So at a time 3 copy of the data has been achieved. Okay, now this data node, suppose 2, will become the primary data node on which the processing will be done. So it will contact to this, and it will be updated that data node 2 is having the copy of the data, it is becoming primary. So on this data node 2 work will be done. So failure will be recovered in this way. If a data node gets failed, so in this way failure can be achieved. So update of the information that data node 6 is the new copy of the data node 1, and now the 3 copy of the data node 1 are data node 2, data node 3, data node 6, which is the, suppose that a.txt was the b.txt will be here, here and here. So in data node 2, data node 3, data node 6, the copy of the data will be stored. Fine. Now up to this we have understood the whole HDFS. Now we will understood the map reduce part, that how this was only the storing the data. Now we will understand how the data will be processed as per requirement of the client. It will send the query to the Hadoop system, and that will, depending on the query, the data will be taken, and on data, that data process will be some process will be done and output will be achieved and will be sent to the client. So this will be understand in map reduce part. So we will understand in, let's understand it in map reduce part. Okay.